It's 7:30. I'm going to get started. Welcome to the Johnson Space Center Astronomical Society monthly meeting. We're still all doing this remotely, as we have from the beginning of COVID. So this is going to be our agenda for the evening. It's a short agenda. We've got just two main speakers. We've got Justin McCollum, who's going to be giving us a presentation on using the planetary program Stellarium. And we've got Star Party news. I know there was a Star Party, so we've got some great news on that to share later on in the agenda. Throughout the presentations, you can post your questions in through either the YouTube channel or directly to jscaslive@gmail.com. By introduction, Justin McCollum is the Physics Laboratory Coordinator for the Department of Physics at Lamar University. He is also an instructor of astronomy for the Department of Physics and a lecturer of space scientists for the Earth and Space Sciences Department at Lamar. He graduated from Portland State University in Oregon with a Bachelor's of Science and Master of Science in Physics, concentrating on optical microscopy in 2005. He has served as a club officer in multiple positions for Fort Bend, North Houston, and Houston Astronomical Society. He's performed a range of official duties from vice president to club webmaster. He writes occasional reports on comets as any recent activity of cometary bodies, publishing the Professor Comet Report. He's a volunteer and building manager at the George Observatory and a part-time educator instructor for the Space Center Houston near the Johnson Space Center. He recently earned a certification in data science with Southern Careers Institute, earning top grades. He's also currently working part-time for Aerial Partners out of New York as a data science orbital mechanics specialist. Works include developing Keplerian to Cartesian algorithms in Python. He's also working on NASA TLE satellite data for tracking shipping globally for the US government. He recently finished a 13-year tenure as the physics and astronomy instructor for the Texas Governor School for the College of Education and Special Populations at Lamar. He's earned awards for excellence in teaching and team participation in course development. Courses covered astronomy experiments with Stellarium, technical physics, introduction to engineering and software development, and programming with Python and 3D Blender. With that, I'd like to turn it over to Justin McCollum.
Okay, everyone, welcome to the presentation tonight, and we're going to go over Stellarium as the common astronomers program. Oops. And what I'll do here is present the topics for tonight. And so what we'll do is that we'll go over the origin of Stellarium, how to install the program, the general tools and features, the program extensions, advanced features, and simulating events. And I should probably see if I can, well, I'll just continue here. So in terms of what is Stellarium? Well, it's a recognized freeware and software program used by amateur astronomers around the world. You can find it in it's available on all the three primary platforms for computers, PC, Macs, and Linux-based computers. It is open source under the GNU General Public License, so you can be part of a community that contributes to the program to enhance it, to add in features, to provide comments of how the software can be improved, or to add in your own features. It is, there are apps for Stellarium that you can find on your smartphone. I'm not too familiar with those. And there's a Stellarium web for Chromebooks. Stellarium cannot be installed on Chromebooks, but if you have access to 4G network or Wi-Fi, you can use Stellarium web. It's just a scaled down version of Stellarium with fewer features. Now, the program began in 2001. It was written in C++. There's a program called Qt, which is basically a widget toolkit in which you can use C++ to create the graphical user interface. That is, you can see the program that's easy to use for operators, or well, for users, that creates pictures and images, and it's a cross-platform application capability, so you can use it on Apple and Linux and Windows. So Stellarium Mobile is what they refer to as a fork of Stellarium, meaning that it's a independent version of the original program. So when you get Stellarium Mobile on the app, it was developed independently of Stellarium, but it's still part of the same group that developed the program. It has a cross-platforming usage, so you can use it not only on all types of smartphones, but tablets. France, every year they have what's known as the La Trophées du Libre, which is basically an international award ceremony for advancements in software, in media, and in the internet. And it won the gold award for their version 7 in the education category for free software competition. So it's won some awards. The current version, of course, there's the 21.1, but I have the one that was released on the 28th of March, and there's work moving towards what's referred to as a version 1.00. Sorry, I can't get the toolbar here to disappear. But it's a great tool for educators, amateur astronomers, and space enthusiasts. You can use this in astronomy labs for schools and higher education. And you just simply go to stellarium.org to install the program itself. So it's available on all internet browsers. This is what you go to, and you go to the website. So you have stellarium.org. There is a user guide. It's version 21.0. And don't know why I can't seem to get my... see if I can get... anyway. Can you get my toolbar to disappear there? But actually, here's 21.0. Here's the user guide. You can download it from the Stellarium website, and it has extensive information, particularly in the practical astronomy. It provides all sorts of mathematical equations if you want to use it for good scientific value for doing experiments or citizen science projects, and in using it as a tool for amateur astronomy as an alternative to buying any software like Sky Tools or Megastar or the SkyX if you're using purely for visual, but it does have some ability to track with a telescope. The appendices are very useful. You get understanding of information on the hotkeys. That is, you can just press a key on the keyboard to activate a feature. There's the Bortle scale and light pollution, star catalogs, configuration files for creating videos, for loading in plugins, nomenclature on the planets. There's accuracy in the proper motion of stars, planetary positions, documentation, the documentation license on the GNU to know about the details of how the program is implemented, and also the acknowledgments, because there are hundreds of people that have contributed in a large international community over many, many, many years. So here are the general tools and features. So you can get up to 177 million catalogs. You have a default catalog of 600,000 stars, but you can add on to it to where you have over 150 million stars, right down to 18th magnitude. You have a default catalog of 80,000 deep sky objects. You can increase that to 1 million. You can simulate shooting stars, twinkling stars, change your landscape, have a telescope control. There's a multilingual interface, and also adding in your own objects, looking at artificial satellites, ability to add new solar system objects. So you can probably do almost all of the observing programs of the Astronomical League for a planetarium program just using Stellarium alone. Okay, so here's the main program as it looks. So you're coming onto the program, you basically have the sky, here's the cloudy haze, here are the cardinal directions. You have the nice blue sky. It tries to imitate as much of the sky with the bright sunny, bright sun. This is the ocular plugin. You don't get this unless you install the plugin, and I can show you how to install those plugins in the program. And here are the cardinal directions. You always open it up facing towards the south. Since, of course, the Earth is rotating in the direction of the north, you're going to get most of your constellations appearing in the south. Now, to access the navigation menus, you have what's called the vertical and the horizontal nav. Now, the vertical nav, you're going to get all of these icons right here. The horizontal nav, some defaults are going to be over here where you have the constellations, over here where you have asterisms, basic coordinate systems, the cardinal directions. This is for the atmosphere. This is the horizon for the ground, the planets, the nebulas, the sky, the red mode, bookmarking, and the forward, going backwards in time. As you add in more plugins, particularly if you have a nice wide screen, you can increase or decrease these plugins, and you get more of these features in the horizontal nav. Now, on the vertical nav, it's pretty simple, and you can just press these keys. I'm not sure how this would work on Apple. I mostly do this with Windows, but you press any one of the function keys. You can put in your location, your date and time. The sky and viewing options windows can change how you want to observe the sky for light pollution, for stars, for deep sky objects. Searching for objects, you can reconfigure the sky when you want to add in plugins. That's reconfiguring the program, the software. Astronomical calculations table, if you want to see what's up available for the night into the future. And then help keys, if you want to figure out what is a perfect hotkey, if there are hotkeys available to use the program. Now, from left to right, I'll just say there's a lot of keys you can use. The basic ones are going to be what I call the CVRB, the 4 constellation keys. And from left to right, you get the lines, you get the labels. When you press the V key, you get the constellation art and the boundaries by declination and right ascension. And then here is the asterisms with the lines and labels. Not all of the coordinate systems are going to use hotkeys. Not everything's going to have hotkey capability. And here are the 3 keys down here, what I call the JKL keys, the JAKL for going to the past, going into the future, the current time, and setting the normal rate. And then you press some of these control-shift keys. When you load in certain plugins, you can switch between, if you want to see pulsars, quasars, see the deep sky images, labeling planets, and flipping the sky between vertical and horizontal, if you want to, depending how you guide your telescope through the night sky. So here's the Explorer Stellarium. We're going to explore Stellarium now. So this is what we get as a fisheye lens with south at the bottom, north at the top. Down here you have your location on the Earth in the lower left. Over here you get the field of view in degrees. This is the frames per second, and this is the international time for year, month, day, hours, minutes, seconds, and where you are with universal time. Now you have the 3 lines of reference. Hopefully everybody knows about the plane of the ecliptic. That's the plane of the solar system. That's the pathway of the suns and the planets across the sky as you go across the constellations along the zodiac throughout the entire year. Here is going to be the equator, the celestial equator, and this is the meridian, where any object reaches its highest position due south, which is going to be its zenith. And down here are the keys. So you push the comma key, you're going to make the ecliptic appear in the sky. If you press the period key, you're going to get the equator. The semicolon, which also is the colon key, you're going to get the meridian. And you don't have to press one after the other. You can have the meridian appear, but not the ecliptic. You can have just the ecliptic appear, but not to worry about the equator or the meridian. And if you want to get rid of the haze that you see around the horizon, you just press the F key to remove the haze. It's known as the fog feature. So if you're building up towards tonight, you can adjust the size of the sky with what's called the page up and the page down keys. So page up, you see a much smaller area of the sky. The page up keys, you see a much page down keys, you get a much larger area of the sky. So if you want to look at a small area of the sky, you go page up. If you want to see a larger area of the sky, you go page down. You activate the location window. You set in your location. If your location is not on the list here, then what you can do is go over here, type in your new location, put in its latitude and longitude, which you can get from Google Maps, put in the elevation. If you don't really care about the elevation, unless you're hundreds of feet above sea level, you can set that to 0. Make sure you put in the right country, the right planet, because if you do this, you can be on the surface of any body in the solar system. You can do this for Saturn and see the rings of Saturn up in the sky, as it would look like if you were on in Saturn's atmosphere. And then make sure you get the sequence right in terms of your time zone. Or you can just get the location from the network. If your computer has access to GPS, then you can get the GPS. And if it's a new location, it's going to recognize it. So you just add it to the list and make that as your default list. Bottom of the screen, I mentioned about the location, the field of view, the frames per second, the international format for the date, and the time with respect to Universal Time Coordinated. And that's the time with respect to Greenwich, England. So once you have that, for the timing window, you can either do this for the date and time, or you can do this for the Julian day, either for the JD or the mean Julian date. And there's actually a web page in Wikipedia that gives extensive mathematics in terms of plugging in the date and plugging out the Julian time. Or I'm sure you can find a program online to calculate what the date and time is with the Julian date. Now, for the keys, you can get rid of the atmosphere. You can get rid of the haze. You can eliminate all of the bodies in the solar system. And this is the same sky. So you can treat this like a true star atlas. And you can move forward in time and simulate the sunset or the progression towards the nighttime. I don't know if anybody's ever seen an image where the sun sets and fast forward and you see that sort of bright, sort of light dome that dims down as the sky abruptly changes in brightness. Stellarium can simulate that. And pressing the A key, of course, you can see the changes in the numbers of the coordinates, because there's, you get the RA in the deck if you're not in an atmosphere, and then there's the apparent because of how the object will shift due to atmospheric effects, and that becomes more paramount as you get closer towards the horizon. In fact, when you see things in atmosphere, you can actually see the extinction, that is, how the magnitude changes as you're looking through a much shallower part of the horizon. As you, instead of looking from here, you look down over to here, you'll see the atmospheric mass actually increase as a number. So you can see the changes in magnitude and know what would be the best to see an object when it's at a certain altitude above the horizon. Hopefully everyone sees the Milky Way right here. And yes, there's a feature where you can turn off the increase or decrease the number of markers and labels for stars and objects in the sky in Stellarium. So important notes, the F5 key is for the date and time window, so you can change your timing. The K key is to stop the time. Usually you want to stop the time first before you activate the date and time window, before you have the date and time window pop up. If you pop it up beforehand and you press the K key, you end up having to click back onto the screen. The window becomes semi-transparent because you get windows that pop up along the main screen to get the date and the time and the location. It can get pretty confusing. The best way to do it is just because you don't want to lose view of the object that you're clicking at and centering the object in the night sky in Stellarium. So what I always do is press the K key for the time, just to stop the time, get the date and time window to appear on the screen itself, set the date and time, and then you can click back on the night sky. You can still have the window up as being semi-transparent. In fact, you can get many of these windows as setting windows to appear on the screen simultaneously, and you can add and remove them or remove them all. And then you can click any icons on the horizontal nav to activate any of the icons if you want to activate or deactivate any of the plugin features, as long as they're installed. So you can add or remove features from the night sky. So it's pretty, it doesn't have a lot of cluttering icons like you can see that you get with Megastar. So it has a much cleaner platform. So these are the types of windows I'm talking about. So you can see when you click on one, you click off on the other one, so it becomes semi-transparent. This is the sky and viewing options window. So you have the options of adjusting the sky. You can change the atmospheric visualizations. You can change the light pollution, the number of shooting stars. You can change the brightness and saturation of the Milky Way. You can make your stars twinkle. And right here, if you bring the labels and markers to a very low indicator here, so when you're focusing on a much smaller area of the sky, those fainter stars, their labels will pop up. So the labeling can adjust based on the magnitude. And you can adjust the limit magnitude for your stars. The solar system tab object, you can adjust many things when you want to observe objects in the night sky on your planetarium program. In Stellarium to simulate it. There's the deep sky objects tab. There's markings in the sky. If you want to mark out, let's say, where the celestial, where the North Galactic Pole is located, you can change your landscapes. You don't have to stick with the landscape you're given. There's the Star Lore tab if you want to look at constellations from different cultures and different professional astronomical surveys. Just be aware that you only want to click on one at a time for those surveys, because if you try to do them all at once, your computer will, well, the program might freeze up and you have to restart it. But here's the search window right there. If you're just typing in an object, you can just type in an object in the search window. It'll take you to the object, either pressing the Enter key, or if you can find the object that appears on the screen, you just press the Tab key. You just click on the object, press the Tab, press the spacebar key, and it will center it right in the screen. So there's the object tab. I don't know if anybody's familiar with Simbad, because it's an international astronomical data center in France, in Strasbourg. All of the tens of thousands of star catalogs and deep sky catalogs have been gathered by amateur and professional astronomers, mostly professional astronomers over decades, are all located right there. So any object that doesn't appear in Stellarium that otherwise you would find on Megastar, you can find those objects in the Simbad, and then it will pop up in the area of the screen as a loaded in new object. The position tab, if you want to just go to an area of the sky in RA and DEC. And then there's lots of catalogs if you want to look at young stellar objects, Herschel objects, the Washington Double Star catalog. And then there's the options tab if you just want to adjust how you want to do things with the search window. Oops, sorry about that. So for the horizontal navigation, there's a lot of plugins, but these are the default plugins you get. So you're going to be stuck with the ground, the atmosphere, the cardinal points, the planet labels, deep sky objects. If you want to pop the deep sky objects in the sky, there's actually a D key. I should have put it there, but it's actually the D key. And then the background images is pressing the I key. And your speed of time, what I call the J key keys, that's the J, or the Jekyll keys, that's the J, K, 8, and L. Now the DSO objects, what are they? Well, those are the deep sky non-stellar objects like nebulas and galaxies and globular clusters. You're just going to get the Messier, NGC, IC, and other objects as the default. So this, of course, is the 27th of March. So this is back when we had the moon sort of rising up past, I think it was in its waning crescent phase. So we have here Vega, Arcturus, and Spica. So I'm pointing towards what looks like a galaxy. When you click on any of these icons, they're going to appear white. When you click them off, they're going to appear gray. Oh, there it is, the D key, or you click on the nebula galaxy icon to activate the deep sky objects. Now, you don't have to have all these labels here. You can go back to the sky viewing options window, and you can adjust the labeling for the deep sky objects in the deep sky object or the DSO tab. So we can make them disappear. Now, the labels and markers in the DSO tab, you can adjust them. So you can have as many objects as you can appear, or as very little objects that you want to appear. And you can do that with or without the markers. In fact, there actually are, with the star tab, you have both adjusting simultaneously the labels and the markers for the stars. Actually, I'm sorry, I think that's only for, I'm sorry, for the stars, it's only for the markers. But for the deep sky objects, you have the labeling, which is basically just the naming of the stars, and the markers themselves to adjust the number of objects that you see. So with the stars, yes, you can increase or decrease the number of stars in the sky, usually by adjusting the magnitude, but you can change the labels for those stars in terms of seeing as many names or as few names as possible. For the markers, you can have you can have a few objects appear as these deep sky objects. So we got the dotted circles for star clusters and the squares for nebulas. You can also adjust the number of labels for those deep sky objects. And you can also have a lot more markers for a lot more objects to appear. So if you have the circles with the crosshairs, those are going to be the globular clusters. The ovals up here in red are going to be the galaxies. And if you see a circle where the crosshairs are on the outside, such as here, that's going to be for the planetary nebulas, like you find in any standard in any star catalog. And that's what you call the Jekyll keys right there, because you can see the sky shifting across. So you can go back to finding the Christmas star around the dawn of the Common Era, or you can go what the sky will look like 10,000 years from now. And you can adjust your field of view and adjust the labeling of the deep sky objects. So for the keys themselves, we already talked about this. You don't have to rely just on the coloring of the outlines here. You can actually change the colorings here. Not so much the constellation art, but the lining of the constellations and the boundaries themselves. Again, you only need to press one of these keys at a time. So you can make the constellation lines appear, or you can just show the art without any of the constellations, lines, or names. So you can look at the constellation art patterns and guess which constellation is which. And you get the boundaries as set by the International Astronomical Union. And asterisms, lots of asterisms. You can adjust, again, the names of the asterisms if you want all the names to appear at once. And you can actually, there are some parts of the night sky where you can focus up close and asterisms will start to pop up, particularly like the Stargate in Corvus, which is really a telescopic asterism. And you get the constellations and the asterisms to appear simultaneously. I mean, you can use this program as a simulation to sort of perfect your methods of doing galaxy hopping and star hopping if you want to do some old-fashioned observing, or you just have like an alt-as drive without a guide program. So if you want to do visual astronomy the hard way. And when you go to any of the features, you can get these squares here, and these are going to be the default colors, but if you click on any of those colored squares, you can adjust the colors here for these bars. So if I make the asterism lines here, if I change this square here to a red, the asterism lines are going to appear red. So you don't have to stick with the colors that are given to you. Now, in going to find an object, we do have our search window. You type in the desired object in the text bar. You get what we call the object reference data. So here I'm showing the constellations and their names. I pick an object in the night sky, and here's the reference data. So right here you can get, of course, the distance of the object, its redshift, its size in arc minutes. You get its coordinates in many different degrees. And of course here you can get your magnitude in per arc minute squared, or you can change it per arc second squared. You can get the magnitude, and you get the Dreyer designation, the Dreyer designation for how the object is described, and then the different catalog references. So this is an image. This is actually through Stellarium. This is not an image I took. This is an image that naturally came with Stellarium. If you were to press the I key, that would disappear, and all you would have is just the position of the deep sky object. But if you press the D key, you can see what the star field looks like absent that object. You can press on the return key or the space bar once you have identified the object in the window that I mentioned. So you type in the search in the search window, where you have the tab for typing in the object you want to look for. You have that in the search window. Type in any object, press the return key, or if you find the object in the sky on Stellarium, you just click on the object, press the space bar, use the page up. I'm sorry, it's the page down to, even I goof every now and then, the page down to make the sky larger, or the page up to make the sky smaller, to focus things up close. Yeah, page up really means you're going deep into the sky. Page down means you're moving away from the sky. So it's a pretty intuitive program. So you get your data. So there's the data up close. You can see the data. So you can get the surface brightness. You can get what we call a contrast index. You can do that for the dark nebulas between 0 and 10 to see how opaque they are against the background stars. So here is the parallax. There's the redshift, the distance, both in light years and kiloparsecs, and the identification of the structure, how you identify it, and then all the different coordinates, RA and DEC. It gives you not only based on the 2000 epoch, but also to the date, because the Earth is shifting around in its axis, so you have to remeasure the position of objects once every 50 years. Here's one for the planet Venus. And so for Venus, you get all sorts of wonderful information, the light time, the distance. This is in millions of kilometers. This is in astronomical units. And for some not familiar with kilometers, an astronomical unit is going to be 92.9 million miles, or 149.5 million kilometers. But you can also say, hey, it took 13 minutes of light time and 13 minutes and 33 seconds of light time for Venus's light to reach us. So it can tell you about how long it would take for a spacecraft to send a message back to us if it's orbiting around Venus. And then, of course, you get the orbital velocity, you get the distance of the object from Earth, its illumination, the phase angle, the elongation, all wonderful, lots of wonderful reference information there. And if you're not familiar with the parallactic angle, it just tells you the position of the body when you're measuring with respect to the North Pole and your particular zenith at your location on the surface of the Earth. So I'm going to open the drapes, and right here you can get the sky appearing as a very dark sky itself. And I always recommend to, and there's actually a statement out there, I don't think you may see it because I don't see it because I'm partially blocked off by my toolbar here. I should have collapsed my toolbar. But basically, I always recommend to put it on the, and if I circle it right there, that's going to be the red eye. So you can make the program look red, put it in night mode. Of course, I always make sure you put the monitor at the lowest brightness and put a red transparency in front of your screen, and then you get a nice red dark. Very good, makes people happy at a star party. Okay, I'm going to go through this pretty quickly in terms of program extensions. So we're diving deeper into Stellarium. So if we go back to the sky and viewing options windows, you can press the P key to eliminate all the solar system's features. So right here, basically with the sky, with the stars, it's not only the labels, it's also the markers. So if you mark a star, you're going to get it to be labeled as well. So if you have the label and marker all the way over here to the max, you're going to get names for lots and lots, for thousands of stars popping up in the sky. There's also a method here called the refraction in extinction settings, where you can adjust for temperature, moisture, and just the extinction coefficient for how the light passes through the atmosphere. Again, adjusting for light pollution. And here, of course, adjusting, you can also have spiky stars. You make your stars look spiky. And stereographic, you can make the sky look orthographic. Stereographic is the default, or even sinusoidal, how you want the sky to appear. And it's all depending on your field of view, because you can go crazy with the star markings and labeling. So here, I set it to 0, and if you're not careful, boom. Now, this is not going to give you the Washington Star Double designation or the Hubble Guide Star designation, but if you click on a star and use Simbad, it'll give you the information about a star which has no designation that appears there on the sky, and say, oh, this is a Tycho star, or this is a Hubble, this is in the Hubble star catalog. Mostly it's going to be with the Harvard, the Hipparcos, and the Henry Drapers, as well as the Bayer and the Flemstead catalog. So you can be very reasonable in showing those common name stars. The coordinate grids, you have lots of coordinate grids. You can even go up to the supergalactic coordinate system. The ICRS is basically an official coordinate system used by professional astronomers. They have slightly different calculations for the standard equatorial system that astronomers use. I mean, there are two versions of the J2000 epoch. There's the ICRS, but there's also the date that we use that we want to see how the position of an object is different today versus what it was done in 2000. So this is the equatorial coordinate system. So there's Polaris right up there. And that's going to be for your azimuthal grid, looking right up. So that would be your zenith. And this is at the George Observatory with the Fort Bend Astronomy Club. Well, actually with the George Observatory in Fort Bend County. Right over there on the right side, this is going to be for the galactic grid, so you can find your galactic poles. And over here, you get your supergalactic coordinate system. So you can do this for many different coordinate systems. You don't have to be limited to equatorial or azimuthal grid. And this is very interesting because you can actually project the lines for the umbria, for the Earth's shadow. It's umbra and preumbra, the circumpolar circles, for looking at precession, the position of the poles, the ecliptic poles, the equinoxes, the solstices. Here, where we're dealing with the equators, you can put in the first row here. This will project the lines against the sky. This will project increment markers, and this will project numbers for degrees. So you can do this for the precession circles. It has something fancy called the colliers, the circumpolar circles, the meridian, the projected solar equator, and on and on. Again, you can adjust the colorings here. So you don't have to be limited to the colors that it shows by default. So you don't get confused between which is which. Also, look at right here for your, this is going to be, let's see, oh, that's your rectangular field of view in terms of how you can adjust your field of view across the sky when you're looking at something either rectangular or circular. So right there, you can see the incrementations. This is going to be the galactic equator. That's a supergalactic equator. And so that's to the left right there. That's to the right. So again, this is going to be projecting the lines right here. This is going to be projecting the marker increments. And then here's going to be the angles. And you can overlap it with the constellations to see which constellation appears where with respect not only to the ecliptic, but also the equator and the galactic and supergalactic equators. Now for here I have Sagittarius, the field of view is 8 degrees. So I press the D key and then the I key. So I get the labels and the object itself as the standard DSO objects. There's also what we call the DSS from the Digital Sky Survey, the TOAST survey. There's also the HIPS options. And so you do different wire mesh surveys, how you project objects in the night sky. You have to be patient for uploading this stuff, so it's best to do it in small areas of the sky. The PDF manual will have lots of information. So this is the Lagoon Nebula. And that's what it looks like in the DSS. And that, of course, is the Deep Sky Digitized Sky Survey, as you see across the galaxy itself. So it's not entirely perfect, different shades of light. It's just based on the instrumentation and the images it was able to capture. But this is sort of a very extensive map of the sky and all the deep sky objects that you can find that are visible from Earth. Now, in terms of the configuration window, you've got the 7 tabs. There's the main, there's the information, times, tools, there's the scripts and plugins. You can basically go to the information tab and change the way your reference object data is displayed. So you can just have these simple letter characters here of delta, of alpha and delta, rather than saying RA and DEC. You can get star catalogs down to 18th magnitude. You can include a compass icon, which shows everything in degrees on top of the cardinal directions. You can adjust for your time corrections feature. It's got different time corrections for timing objects when they appear. The Espinec and Mias is the default one from 2006. Scripts are basically playing videos on Stellarium. And the plugin tabs is to add in extra features, like if you want to see quasars or exoplanets. And so those are just the different ways you can arrange your coordinate systems and your data on your objects reference system, if your objects reference list, your data reference list, and how you want that reference list to appear. And right there is going to be for your compass marks, where your cardinal directions is going to be to the left, and then to the left of that is going to be what looks like a sun with clouds. That's the sky feature, and then the ground feature is the last one on the left. So this is your window key. It's a bit cut off there, but you can actually get your tab keys for the date and time display options, the help window, the astronomical calculations window. Here's a list of the different types of features. This is a bit cut off here, but you can be a part of the Google group. You can suggest options for adding in features, download extra landscapes, download extra scripts, and simulate them on the program itself. And then, of course, here's all the tabs. So you can do angle measurements. You can look at meteor showers. You can do pulsars, quasars, satellites. And, of course, you can have your navigation stars and bright novae and look at historical supernovae. So here is the 3D sceneries. So whenever you go to the configuration window, you click on a plugin. You load it at the startup, so you have to turn off the program to reload it. But once it's reloaded, you can go into the configure window and change the features. And you can change the features while the plugin is still loaded into the program itself. And if you want to turn off a feature, you just simply click off the load at startup if you don't want to deal with it, rather than having to turn on and off if you're worried about having too much icons on the horizontal nav. And you can reconfigure how you want to see the quasars, pulsars, or how you want to reconfigure each one of these plugins. So you can change all the types of features that are available to the program. You don't have to stick with the defaults. So this is the sky and viewing options window. You have up to 24 different deep sky catalogs. You got the Kolinder, you've got the Vorontsov-Vel'zhenminov in Virgo, the ARPS, the Abell galaxy clusters, the Hickson groups, the planetary nebulas, and the different types of bright nebula catalogs and galaxy catalogs. You can filter by type. You can also filter by labels and markers. You can also change terms of surface brightness and outline features. So you can make your maps look as sophisticated, nearly sophisticated as what you would see with Megastar or Uranometria. So here we get our objects. This is looking towards the south along the Milky Way. And you can see the outlines right here. So this is the horse, what I call the dark horse, the horse dark nebula in Ophiuchus. And of course, you can adjust change the sizes of these markers depending on brightness. So you can make some of these dotted circles look larger, some of the squares look larger, because the smaller the sizes of these markers are, it's directly proportional to the brightness of the object or how much of the sky that object will cover. Now here's an area where we got some galaxies. We've turned on the image feature, but we don't see the galaxies, so we don't see the images of the galaxies, so we don't know what they look like. Well, if you activate the DSS, boom, then you get to see what the galaxy would look like. So it gives you the basic image of what you would expect when you're doing imaging. If you decide to use Stellarium, not so much as an imaging program, because mostly it will just be for guiding telescopes, but as a planetarium program to use. The sky.
Hey, Justin?
Yeah.
Could you go back a couple of slides? Do you have to add additional catalogs to select the ones listed?
Right here? No, you just click on them. These catalogs right here is the catalogs that are available. You click on any one of them, they'll pop up on the screen. You don't have to reload the program. I mean, if you're looking for something like a Herbig-Haro object, it's best to do it through the Simbad, which is a feature on Stellarium, and then it will pop up the location of the object in Stellarium itself.
Okay, thank you.
Mm-hmm. Yeah, you just click on any of these clicks right here, and those objects will pop up on the screen. I remember a time where there was only 4 or 5 catalogs with Stellarium, but now it's now up to 24 different catalogs. Okay. Okay, the sky and viewing options window. So you can just pick any culture, so you're not stuck with just the constellations that you see in the modern. You see here, these are the constellations of ancient Babylon in the Seleucid period, which is sort of in the last 200 years before the Common Era. The Chinese, of course, have lots of constellations. Again, you can adjust the labels for the constellations. And here's the Navajo culture. So you have dozens of different cultures in which you can see the different types of constellations by different cultures. This is the Sky tab, so you can make your stars twinkle. You can adjust the position for how you want the sky to appear in terms of light pollution. You can adjust the rate of shooting stars. So this is the sky you would see in Houston with the value of 9. This is a 5, and that's a 1. And the atmospheric visualization, you can adjust the extinction coefficient for how dim the object will get as you get closer towards the horizon, the atmospheric pressure, and adjust the temperature if you're at high altitude. And this is the Milky Way. Now, there's what we call the brightness and saturation. So the brightness, if I remember right, is from a factor of 1 to 10. So you can make the galaxy look very faint or very bright. The saturation is from 0 to 1. So if it's 0, it's just going to appear black and white. So you can make the Milky Way look different in terms of the amount of color and the brightness, depending how real you want to appear in the sky. The solar system tab object, you can go over here to custom settings with the great red spot and use a program called WinJupos. It's a nice freeware program if you want to see where the great red spot is appearing when it comes in front of the daytime side of Jupiter. I don't have time to go through all the WinJupos. I can do a separate presentation on WinJupos, but if you want to know details about how the great moons are orbiting around the planets in the outer solar system, WinJupos is a great thing to use. Also, there's changing the markers and labels for asteroids and comets. You can scale the different sizes of the planets. There is the planet magnitude algorithm. You can change that. There's also what we call the Dajon scale, which basically deals with the intensity of the luminosity of the moon during a total lunar eclipse. So this takes you right, when you click on that feature, when you go back here and you click on the custom settings for GRS, then the GRS detail button here becomes active. And then you can see where you are in terms of the date. And of course, this uses the system 2, which is looking at the coordinate system for right ascension and for latitude and longitude in the mid-latitude regions for Jupiter. So I'll be happy to answer any questions about that. And of course, changing the longitude, the drift, and the date and time, or you can view the recent measurements right here. So if you want to view the recent measurements, this screen will pop up. So you can make Jupiter appear very large or very small. You can eliminate. This is exactly the same area of the sky in terms of the same field of view, angular field of view of the sky itself. So you can make Jupiter appear small or big, and you can either show the orbits of the moons or not the orbits of the moons. And you're not limited to just the Galilean satellites. You can allow all the little other moons to appear. So for the advanced features, we should probably go through this as quickly as possible. So exoplanets, pulsars, and quasars. The red, you'll get the navigation stars. The lower left, of course, right here, if we see this, the lower left right here, this deals with the observability. So you can see when an object rises or sets. If I pick a quasar, and the quasars are going to be these red dots, The greens are the planets, and the blues are going to be the pulsars. This is the survey from the Kepler mission looking at Cygnus with all of those exoplanets. And you can see time of observability right there in the blue on the lower left hand here of the upper big screen. Now, if you're looking here with the right here to the left is going to be for details on exoplanets, in the middle is pulsars, and on the right is going to be quasars. And of course, you can actually manipulate the coordinates of the mouse pointer right there. And then, of course, there's navigational stars. There's actually what we call an angle measurement system, where you can measure the angles between different stars, between different objects, compare them with asterisms. Here, of course, you get the mini Cassiopeia right here. That W you can see inside the summer triangle. So right here, when you're doing an angle measurement, you get the degrees right there, as you can see below the lower right there. You see this is 14 degrees from Altair as a navigation star towards the dumbbell, towards the dumbbell nebula right up here in the little W. And you get that up close where you can measure the angles and the degrees. So it's very good when using your arm lengths when measuring in terms of the 5, 10, 15 degrees you use with your hands and fingers. You can use this as a skill when it's cloudy at night to help with star hopping and galaxy hopping across the night sky. Let me see here. Running low on time, you can do this with the analemma, which you can look at the position of the sun as it changes throughout the year at a particular time. So we see the changes where they are. The equation of time is where the object deviates from the meridian. So you can see how it changes through the sky itself. And then, of course, there's the plug-in for the compass. So you get the degrees, the numerical values all around there. Hopefully you see the numbers right there along with the cardinal directions. And we can go all the way to right here where we can, of course, see the constellations. You can get the Polaris Galactic Borealis. And right there you can look at where we get the galactic North Star. So there's a galactic North Star on top of a celestial North Star. Meteor showers. You can always adjust for meteor showers. You can pick out your meteors right here, knowing when the dates are going to appear for the meteor showers. You can simulate the meteor showers. You can get the radiance to appear. Right there is where you get the radiance and the information on the radiance, which has the magnifying glass. Satellites, you can get the two-line element data for the satellites. So you can pick any particular satellite. So I circle the red there. And you get the TLE data in terms of coordinates and velocities, X, Y, Z. The ocular plugin. This is pretty fascinating because you can put in information about your sensors for astrophotography. You can look at optical properties of your telescopes and eyepieces. So this here, this right here is going to be for the eyepiece. That's going to be for the sensor. This is the telrad. You can adjust the telrad. There's a feature here where you can adjust the telrad, so you're not limited to half a degree, 2 or 4 degrees. You can change the angles and include a 4th ring. So you can have a 4 circle ring telrad. So I'm going to do this pretty quickly because you can change your eyepiece and simulate what you're seeing in the telescope with a particular eyepiece and a particular telescope. You can also put in your compass marks. You can also do your angle measurements. You want to go off of this tab for a moment. So you want to click off from the oculars right here temporarily to activate the celestial sphere in the sky and viewing options, because then you can bring in the grid system right there. And this can serve as a virtual version of a bifilar micrometer, like the old Van Slyke instruments. You can see how your objects are moving across the sky because you can impose your images with Stellarium. And what's important is the plug-in for your telescope. In the past, there used to be a program called Stellarium Scope WD, which we still use at the George Observatory for the Fort Bend Astronomy Club with their East Dome telescope, where you had to get this program, and then it would communicate with a driver that has the ASCOM in order to operate your telescope with Stellarium. That feature no longer exists. Stellarium 21.0 now has it built in as a function. So all you really need now is just the ASCOM driver with your telescope, so you can run your telescope drive with your telescope across the sky. So you just have to put in your information to the telescope and make sure it communicates with the ASCOM controller with your telescope drive. And this is just the default if you want to navigate by Alt-AS for the Control M. And that's right there for that feature to activate the telescope feature. Okay, so for simulating events, I know we're short on time, but the important thing is doing the lunar eclipse. And I did this for 2047. And so what you do here is you pick the eclipse. So this is the sky in Hawaii in 2047. You get the moon, you can see the changes in the umbra and the penumbra, in the umbra and penumbra, and that's what the moon's going to look like. So what the interesting thing about this is that we're getting the moon pass through the greatest extent of the for a lunar eclipse around the Earth's umbra. Usually it's above or it's below it, so you don't have a long period of time.
Where is that in the software again?
For doing the eclipse?
Yes.
Well, you can just put in the date and time and the location that you get going to the NASA Eclipse website. You can put that information in Stellarium. And then once you have that location, so if you look here, you can see where it's going to be visible here in Hawaii. You get the data here from the NASA Eclipse website. You pick the eclipse where it's going to be visible. And then you just go to that location, like this is in Hawaii. So you pick the location, you pick the date and time. The sky will pop up as it looks like at this date and time in Honolulu, Hawaii. And then you just go forward in time to when the eclipse, or just see it in what would be like in real time. And it's just as simple as that. This is, I'll just go through this quickly. Here's the lunar eclipse on the 25th and 26th of May this year. Here it is in 2047. If you're not familiar with the Jejon scale, it basically deals with how good of an eclipse, total lunar eclipse, you're going to get. So if the moon's at its furthest distance from the sun and it's only glancing along the umbra, you're just going to get this sort of copper color with a bright bluish rim. Where if it's very close to the Earth and it's passing through the shadow at its greatest extent through the Earth's umbra, then it's going to be a D0. So it almost is going to be invisible, like a black circle in the sky where the moon is. Other simulations, this of course, if you go to the inthesky.org, you can use a program called Occult version 4, another freeware program, to determine when bodies are going to be occulting each other. And this is just doing the occult of Venus across the moon. So you get the data from either from the Occult V4, or go to the Lunar Occultations website, or go inthesky.org. Just plug in the location, the date and time, and you get the simulation. You can do also the same thing with conjunctions, and you can just simply change the scale of the bodies, use the angle measurement. Make sure you turn off the angle measurement every time after you've used it, otherwise you won't be able to navigate across the sky if you have the angle measurement taking place. And then, of course, the astronomical calculations window right here. So this, you can just look at any type of objects in the sky when they're going to pop up for a particular date. All of this shows you what you can do to sort of get a prediction of what the night sky is going to look like anytime in the future, or look for any events in the future, whether it's planets, stars, deep sky objects, or any celestial events. You can simulate, of course, plotting of objects across the sky. This is with respect to Venus and Saturn, so you can simulate the retrograde loops, the epicycles. Here's one for the 2117 Venus transit. So you can plot this over a period of 2 days. You can put, you can just set your ranges in terms of time increments, time ranges, and between any two events. It's always good to refresh and everything here in the position, the ephemeris, and the transit. So you can just simply clean up the ephemeris, or you can change them. I would clean them up every time along the positions, the ephemeris tab, and the transit tabs. That way it cleans everything out and you avoid any visual errors on the view screen. And of course, this is very good for using for comets. And here for the plugins, the solar system editor, you can do the astronomical calculations table. So you can watch how a comet is moving across the sky, where the tail is going to be positioned. You can see the magnitude. It's the size of the comet in arc seconds. It can give you the core diameter. It can give you estimations for the tail length and the solar and lunar elongations. So we do this graphically here. You have any combinations. You can look at comparing distances with the elongation, its separation from the sun, the phase angle with respect to magnitude, the transit altitude, how high it is above the horizon due south compared, let's say, to its hour of right ascension, or the angular size compared to its declination, and the timing based on the number of years. It doesn't give you the position angle or the tail foreshortening. But so it does not entirely replace programs like Astrograph or SkyTools or the MPC Comet Ephemeris service if you want to get more details about the orbital elements for the comets, but I think it does a pretty good job for a freeware program. And then, of course, there is the, this is what we call What's Up Tonight. So you can pick any time of the night. You can pick any variety of different objects. There's dozens of different categories here. And look what objects are going to be available tonight. And you can save your list of objects. And then there is the PC for what's known as the Planetary Calculator or Positional Calculator. So this looks at the position of where Titan is with respect to Saturn. Look at the separation of the two bodies and the distances between the two bodies. So you can see how basically Titan as a moon is actually precessing around the planet Saturn. So it's a great freeware program. It's evolved a lot. There are many more features to be added. It will predict eclipses, transits, occultations, conjunctions, movement of artificial satellites. You can connect it with Sinbad to look for some obscure deep sky objects. And there are new features being added in all the time as you go from a version 21 to a 22. And it's a great program for amateur astronomers to use, for educators, with education projects, and executing citizen science projects. And unfortunately, I didn't know, because I have the toolbar here cut off, I had a little thing about where is 42, how to find 42 if you're familiar with, or the secret to 42 if you're familiar with the Hitchhiker's Guide of the Galaxy. And all I can say is I found 42 and it's everywhere, because there's Jackie Robinson's number with the Dodgers. Here's the energy efficiency with black holes, molybdenum, the ASCII key, M42. This is the 3x3 magic cube, where if you go along horizontal or vertical along any lines of stars or cross diagonal, the number adds up to 42. So, and that's it.
All right, Justin, back in where you had your different views in Stellarium, do you have something already loaded with the for the astrophotography on your, so you could show what an object might look like?
You mean in terms of looking what a deep sky object would look like?
Right, right.
Well, does everyone see this? You see it right here where I have Stellarium up?
Yes.
Okay, so I can just do the D right here for the objects. And, if I go to Ptolemy's cluster right there, maybe I can remove the atmosphere. And then what I'll do is do the page up key. There's the star field right there. Let me see if I have the image. I think I have the image right there. And if we want to use the DSS right here, for some reason it's not, oops, no, it's not giving me the DSS right there for some reason, because I don't have access to my horizontal nav right there. But you should be able to see the objects here. Let me get the I key to show. Okay, there it is there. Right there. And of course, you can come over here to, let's see. Here's the, okay, here is the Ophiuchus star cloud to give an idea of what you expect to observe. And I'm not sure why I'm not able to, why I'm not able to use my toolbar here. So I guess I'm having a glitch. But when the toolbar rises up here, you should be able to activate the DSS feature here. And let me see if I can collapse this here. Oh, shoot. Okay, I probably should have collapsed this toolbar here. Let's see. Shoot. Okay, let me see if I can just get, oh, it's got two of them here. Let me see if I get this here. No, I can't seem to get it because that's the only thing. So when you have your toolbar here, you want to be able to collapse that. Maybe if I can just simply get to that. Usually when I have help, usually I can come over here to the help window and see if I can do the DSS. Let's see, deep sky objects. Let's see if it gives me right here for the DSS. But if you click on the DSS, you're going to get the object to appear as it would appear on the DSS itself. But yeah, I mean, you'll get something that looks very similar like that. So sorry, I'm not able to get my DSS. I should have been able to collapse my toolbar there. Unless you collapse your toolbar down here, which is of course this toolbar, you won't have access to the horizontal nav, and that's one of the only drawbacks. That's one of the few drawbacks with the program. So, but that's it. Anybody else have any questions?
Yeah, there's a couple more. So are all 24 catalogs come along with it by default, right?
Yes. I mean, if I were to go here, for instance, sky and viewing options window, so I can plug in Barnard's, ARPS, Paracahutex, Abels, and you can see how every time I plug in an object, my variety of deep sky objects only increase.
Okay. And one more, can you tell us one more time how you load new Comet data?
If you go over to here to the sky, and actually, it's actually going over here to the configuration window. So you have your scripts. No, not the scripts, I'm sorry, the plugins. There is what I call the solar system editor. So I've already had this loaded up. I go to the configure, and there's actually what we call import add minor solar system objects. The simplest way to do it is to go to the solar system. You can import orbital elements from the MPC format right here. You go to the comets, select the bookmark so you can get your MPC list of observable comets. You have your MP Corp comets, which includes observable and non-observable comets. And you can get your orbital elements. You can download them, and you can either overwrite the selective objects, you can mark them all and update everything, and you can even overwrite the existing objects only, and then you add them. It's loaded up, and then you can just close off the configuration. You can close off the windows.
All right, thank you, Justin. I'm going to send it back to Chris.
Okay.
Chris, you have a go.
Okay, well, Justin, thank you for a very thorough and deep understanding there of Stellarium. That's amazes me that you can do so much in software that's just been built up over the time for us astronomers. Absolutely fantastic. Thank you for that. The great thing is that Justin's presentation is also going to be available on the YouTube channel. If you subscribe to our YouTube channel, you'll be able to play back and get some more of that detail, because I don't think anybody's capable of learning that just by looking at one presentation. The proof is obviously in playing with the software, using it, and really doing a lot of clicks on the software to learn it. But very, very thorough. Thank you, Justin, for deciphering that for us. Much appreciated, and really enjoyed the 42 comment. I'm sure the answer, the ultimate answer to life, the universe, and everything is definitely in his presentation. So do check that one out later. Next up, we have David Haviland with Star Party News.
David, you have a go.
All right. Yeah. Thank you very much, Justin. That was good. All right. Star Party is going to be a little short and sweet. If the slide will advance. Anytime today. There we go. July 17th, we had an event at the Hack Winery, which fortunately, for the first time in a while, was not rain or clouded out. We have an event coming up on the 17th, same thing. We are still thinking about holding an all clubs meeting virtually on the 15th. And while October is not too far away, we're probably not going to do a day, but we're probably still going to keep it as the George being open and theme it as an International Observe the Moon night. It'll be a first quarter moon that weekend. It is also International Observe the Moon night with the Night Sky Network as well. So we're probably not going to do the a-day scenario, indoor-outdoor talks per se at this time. November 1st through 6th can be the El Dorado Star Party. That's been and Fort McCavitt overlaps that a little bit from the 4th to the 7th at the fort. And we finished the year back at the winery. On the 17th, we had appreciation to Bob and Leslie Eaton, Chris Wells, Chris Randall, myself, and Karen Nickel came out with the Pearland High School. I think it was a 10-inch, 8-inch or 10-inch Dob that the school had bought for her, and she was working it out quite well. Oh, and I'm going to apologize ahead of time to Chris Randall. I totally hosed on your transit. We will show that next month. I just remember that because I saw his name there. I said, oh, I knew there was something I meant to put into the Star Party report. I had an estimate of 100 to 120 to 150 in attendance. Skies were soft. We had a decent first quarter moon to work with. We did have the Saharan dust out there that night, which made even finding basic stars tough to find at times. There has been an enormous amount of construction going on, as you can see over here. This used to be where this building is, where this right side of the mouse is. That used to be the pathway from the parking lot over. Yeah, these are ruts from tractors. So they're doing an awful lot of construction out there. For those that haven't seen, this is the new winery room that they've got going on the inside. This used to be an outside deck. The old wine tasting room was inside this. Okay, out here on the grass is where we were. The large deck area had a very large tent on it, so we've been kind of getting used to setting up on the deck. This is Bob Eaton, Leslie Eaton, and Chris Wells getting set up. Here's Chris's big beast that he chose to bring out. It's Chris Wells and Bob Eaton again. Bob brought the Mulon out. There's Bob and Leslie over here. Chris and Karen Nickel getting ready and finishing off a glass of wine, finishing off a meal, getting ready for the night events. And we had a number of takers throughout the evening. The sun was hanging low in the western sky, and some people, Karen had a solar filter for observing that. I had a Dob there, but most of us were either on the moon or trying to find often difficult to find objects. Again, stars such as Arcturus and even Vega were a little tough to identify. And it made things like the Saharan dust made things like M57 impossible to see. Things are hopefully, we're hoping that things were going to get going again. But as many of us know, Delta has a slight change of plans for us, and hopefully Lambda will stay at bay too. Not to get too involved with work, but we've now system-wide Methodist has 725 admits that are now COVID. And to finish off, to boldly go where no van has gone before. That's the Star Party report for August. Thanks a lot.
Okay, back to you, Chris.
All right. Well, thank you for the Star Party news, David. Yeah, I went to that Hack Winery Star Party. Let me tell you, it's absolutely awesome to get back out there in front of people, and we had an absolutely great time. I really like what they're doing, by the way, in the Hack Winery. The new bar is absolutely awesome looking. So love that experience, and I'm glad we've got another one of those set up for September. Just a few closing remarks. Thank you again to our main speaker, Justin. Much appreciated for that. I'd like to just point out that this presentation is going to be available on the YouTube channel. So we're at JSC Astronomical Society. Do subscribe to our YouTube channel. If you got questions you want to contact any of the speakers, do contact us on jscaslive@gmail.com. And for the next meeting is going to be on September the 10th. And we're going to be doing, it's actually going to be David Haviland doing the main presentation on updates to lunar imaging. And I've also heard that there's going to be some DIY astronomy presentations in there as well from a few of the other club members. So with that in mind, look forward to for you guys tuning in next month. Thank you. Good night.